Okay, cool. So a quick intro about who we are. Our company is called Triality, and we're building a decentralized knowledge sharing platform for Web3 developers. Who we are, I'm Mikey. This is Matt. We are co-founding this company together. We both went to Berkeley together, studied computer science, went off on our own paths, really loved the whole working in industry, but found Web3 and were instantly hooked. And we realized that there's not much community documentation around Web3 for programmers and people who are interested in the technical space. So we decided, let's try to innovate in a Web3 manner. Let's not just use Stack Overflow forever, per se. So some of Triality's goals, we want to build a bunch of innovative tooling for Web3 developers. We don't want to just have forum posts that are just plain text that people use to copy and paste into their own projects without any reliability. We want to see if we can do better. So currently working on a bunch of tooling right now exclusively for the Starknet ecosystem and for Cairo in particular. We want to allow for content ownership, management, and monetization by users. So if you ask a question, you should be able to put a bounty on that question that you can actually pay out for someone to answer if you need it. You should be able to put a paywall around really important information that you've created to allow others to pay you for the time you've spent building useful content. We want to bring spam prevention to the community. So users look out for other users' content and report and can slash funds from users by challenges, basically human to human challenges. So we would allow all users to be moderators in terms of spam. So we don't have to hire a centralized group of moderators similar to most of the other Stack forums. Knowledge bounties, similar to what I mentioned before, the ability to pay for useful information that you need or you believe other people need. And we're always looking for community feedback. So if anyone has any questions, comments, concerns about anything on our site, whether it's the design, the features, the content, let us know at any point. We're pretty quick to iterate and turn around to get out the features that people are looking for. Today, Matt and I decided we would do a end-to-end walkthrough of a demo creating, deploying, and testing a Cairo smart contract, and then building the front end to hook into it. So basically take you through the full process of what it would be to create an application hooking into the blockchain that's been in testnet for Starknet. And basically what we're going to make is we're going to make a game where an admin user sets a number on the screen and other people are trying to guess the sum of the digits. So we're going to have to use some Cairo recursion to write our contract, and we'll be using Starknet JS and Starknet React, doing some comparing and contrasting between the two. Excuse me, between the two. Once this is over, if you want to check out our project, we've posted all the code in GitHub, and we'll distribute the links on Twitter, and we'll send it to the Topology team so they can distribute as well. All right, let's get coding. So first thing we're going to do, so I have a blank Visual Studio Code project. So for everyone on the call, this is going to be a rather technical meeting. Let us know if you have any questions at any point. Happy to answer any. I have a Visual Studio Code project open. I'm going to start by making two folders, a contracts folder and a tests folder. Inside of contracts, I'm going to create a demo.cairo contract. And inside of my test folder, I'm going to make a demo test.py. So we're just going to create some simple tests as well. Okay, so to start, I've already initialized my Cairo environment in my terminal. So we'll be compiling throughout the talk today just to make sure everything's working smoothly. So to start, to save a little bit of time, we're going to start by copying over the base storage variables and getters and constructor for our contract, and we'll go through those, and then we'll start writing some code after. So copied from that GitHub, we basically start this contract with the identifier that this is a Starknet contract. We have a bunch of imports we'll need for our contract, and we begin initializing our storage variables. All the storage variables are, we use the storage var decorator, and the pattern in Cairo is you create this function and return the type of object you're looking for. So we'll need an owner, we'll need wins by address. This will be based on an address passed in. We'll get the number of times someone's won, the last winner, which is an address, just a felt in Cairo, the current number that's trying to be solved, and whether or not the game is active. We will have a constructor designated by the constructor decorator, and we'll pass in a bunch of implicit arguments, and then we'll have an explicit argument, which is the owner address. So whenever this contract is deployed, whoever the owner is will be written as the owner of the contract, and only they will be able to update the number. Couple of simple getter functions here: get owner, get current number, get is active, get last winner, get number wins. These all correspond to getting the storage variables above that Matt will end up hooking into in the Starknet JS and Starknet React code. And from there, we will, let's compile our code really quick. Just make sure everything is working. So we use the Starknet compile command from the command line, and we see that there's an issue. It's because I'm in the wrong folder. So let me see cd into contracts, run this again, and to get all good, we have compiled our contract. So currently no syntax errors. So what we're going to start with now is we're going to work on the function to verify the sum of a particular number that's passed in. So let's have a look at that. I've just copied over the method signature here. We'll pass in some implicit arguments, and then we'll pass in a user answer, and we'll return whether or not their answer was correct. So given the number 123, we would do the sum 1 + 2 + 3. So for this function, I will need some local variables. So always, whenever you need local variables, you should always use the alloc locals at the top of your function. And then let's ensure the game is active. If not, we'll make an assertion that fails. So let's let active bool equal is active dot read. So here we're reading from the storage variable is active, and we want to ensure that the game is active for us to be playing. So whenever you're using assertions, it's best practice to use this with adder block and provide an error message. So when debugging, it's a lot easier to find where this assertion is coming from, as opposed to finding something like assert 1 does not equal 0. So I'll leave a message, this game is not active. So we'll get this error message in the case that this assertion fails. Active bool equals 1. And then let's get our current number. So I will let cur_num. So this is getting the current number from the storage variable. And then let's make a function where the logic will actually come into play. that finds the sum of the current digits. So say, for example, at this point, we had started writing our contract. We realized we get to this find sum digits function that we didn't know actually how to write this recursive function. It's a difficult function that we want to either get review from or just generally need help with. We'll give a quick blurb on how you could use a recent feature on Triality to solve this issue. So let's say I decide I need some help and I need to figure out how to do this. So you could come to ask a question in Triality. You say, how do I calculate the sum of the digits of a felt in Cairo? And given a felt, so we give a body to this. Given a felt, I'd like to get the sum of the digits. For example, 123 would be 1 plus 2 plus 3. And this is a good candidate for our verifiable coding question, which basically allows users to ask community, sorry, I'll sign in, to ask community unit testing questions. So I can ask for a particular problem statement and then define my inputs and outputs. And then users will provide me answers that need to satisfy the inputs and outputs. And we'll show how that mechanically works from an answer perspective as well. So say I know 123 should be 6. I know 577 should be 19. And I know 88888, say, should be 40. And I'll enter a tag, Cairo, and I will post the question. So imagine I had posted this question and now it's basically built in the mechanics so that if a user comes in, a different user, imagine I logged in as someone else, they would come in and be able to see this. How to calculate the sum. These are the inputs. These are the expected outputs. And then as an answer, you can provide your answer into our code editor. So for the sake of time, I will pretend I'm a very good, quick programmer. I saw the question. I was able to come in quickly and realize how to solution for this. So I write this wonderful code. A couple things about our framework is the entry point of every test that you run has to enter through the function called Triality. Triality can have as many implicit arguments as you want. For now, you can only have one explicit argument and it has to return one value. We're currently working on making this fully functional so you can pass in as many arguments as you want and return as many arguments as you want as well. And just make sure that there's no references to main, a function main, anywhere in your code. On the back end, we use some main processing. And if you have any questions, you can just hover above this light bulb, and we have all of our requirements for the editor here. So feel free to just look there. Once you've put your code in and you feel comfortable, you can test your code. So on our site, we will actually run your code against the Cairo compiler, and we'll provide you with an output of what happened. So let's take a quick look here. So for test 1, the input was 123. The expected output was 6, and we got 6. So we got this green check mark, and the same is true for all of the tests. And we even provide you with like the number of steps it took for your program to run. And we'll be providing a bunch of metrics in the future. Say we had messed up this function, and instead of starting with a sum of 0 to begin with, we had started with a sum of 1, just to show what tests failing look like for someone using this. You would get, something like I input 123, I got the expected output was 6, but I got 7. So you'll get this assertion error and go back and resolve everything in your code here. You can run everything from the editor, basically get the same that you get like using the Cairo playground or running in a compiler. We'll show you your error messages. So let me just fix the code. So now that all the tests are passing, I'm still the person writing my contract. So I realize, okay, let me take this, find some digits. This is exactly the function I need. and let me paste this in my contract. So I realized that the person who was kind enough to help me with this had, and let me actually just post this answer. So now this answer would be public for anyone and everyone who wants to come in and check out how that was solutioned. And people can give comments or determine whether this was a good answer. And if they think they can do better, more efficient, etc., they can provide their own answer. So we can see that the implementation actually didn't take in one argument. It actually took in two. So I'm just going to pass in a 0 here as well, just to get everything lined up. And say, I'm super grateful. I got this function from Triality, from someone who helped, and I want to compile my code. So I come back, compile my code, and I need to save. So it's not active. Missing a semicolon there. Okay, so we get another error. This is saying that expected expression of type felt got res felt. So imagine I'm writing my my contract. I'm like, oh no, I'm screwed. I don't know what happened. So I take a look at the line. It looks like there's an issue passing kernum into here, and I'm a newbie to Cairo, so I don't know what to do. So I go to Triality, check out. I post the error message into the search, and I find exactly what I'm looking for. Cairo error, expected expression of type felt, got res felt. So I have a look. This looks super similar to what I'm looking for. They basically are passing this kernum into define some digits, and this is the error that I'm getting as well. So let's see how it was answered. It looks like you have to take the return values as a tuple when you're returning from a function. Oh, of course, that's in the documentation. So let's fix that by putting our parentheses around kernum. And it looks like we just need to return is correct. We're just missing a return statement. And now we should compile again. Yep, okay. So we're compiling successfully. Now we're just missing the logic to check whether the users has entered the correct number. So I'm just going to copy this code in for time's sake, make sure we're still on pace. Basically, if the user's answer equals this res that we get back from the sum digits, we'll get the caller address. We'll write that the contract is active. We'll say that the wins, we'll get the wins by this particular address. We'll add 1 to them and rewrite that to the wins by address. So now the person who just answered correctly has gotten another win. And the last winner will be the caller. Lastly, we need to write an isOwner function. So only the owner of the contract can update the current number once the game becomes inactive. So let's do that really quick. So this isOwner function similarly uses this get caller address. This is a function from the Starknet common syscalls. So basically gives us who is calling the function, calling the contract. And we basically just take the owner, read it, and confirm that they are the same as the caller. And if they are, then they are the owner. Lastly, let's write our function to update the current number. So to update our current number, we want to ensure, so we had to write this isOwner function to ensure that only the owner can write a new number. And again, we'll run this assertion wrapped around an error message. So if they're not the owner, we need to make sure we provide good error messaging for the users. And then we'll write that the game is active and update the current number via what's being passed in from the owner. So let's, one more time, compile, make sure all is well in the contract. And then all of this again is in the GitHub repo. So if you want to go more in depth, or if you have any questions, feel free to reach out to us. I'm going to just copy and paste all of our tests here. But basically, what I recommend is while you're writing your contract, you should be writing tests along the way to make sure that the functionality you're building is all correct. In this case, I'm just going to copy it in and just show how you can run tests generally. So I've added inside of this demo test.py file a bunch of imports and some setup. So our setup is we need to use this at PyTest async IO fixture, which before every test will basically deploy a contract so we can get a new contract and then run functions on it. And then I run through some simple tests of getting the current number, checking that the guess is correct, checking if what happens if the guess is incorrect, setting the number with the owner, setting the number with the non-owner, getting a Starknet exception, and guessing two correct in a row and seeing how all the values are updated. To test this, we'll need to go into our tests folder and we'll just run PyTest demo test.py. I need to save this file. And while this is running, basically, these PyTests can take a little while. There's a bunch of other tools and test frameworks that are a bit better, but we didn't want to jump into all of that in one call. So far what we've done to recap is we've written our contract, we've written tests, and we're pretty confident we want to test it live on the testnet. So what I'm going to do now is I'm going to deploy the contract to the test network, and then we're going to build our web app around it, Next.js app, to test against the contract in real time. So let me set my network. So whenever you're going to deploy, make sure you run this command, export network, alpha Garley, and then let's deploy the contract. When I'm running this deploy command, one interesting thing is I'm passing in this address. This is what's going to be added to the constructor, which, where is it? Here. This is going to be the owner address that's passed in. So this right here, this argument is making me the owner of this contract. So the deployment was successful. We got a result of our contract address and transaction hash. And let me take this contract address and I'll send this over to Matt, who's going to use it to call our contract from the front end using Starknet React and Starknet JS. And he'll show what this looks like in Voyager, the block explorer, once the contract has been loaded. So let me send that over to him. And then I will let you take it away from here, Matt.
All right, thanks, Mikey. So now that Mikey has deployed the contract and sent it to the testnet, our goal now is going to be to write a UI. Let me just share my screen real quick. Can you see my screen? Good. So we want to write an interface, a web application, a web page that is going to interact with this deployed contract. So I'm going to kind of show two different ways that you can do it. I'm going to do one with Starknet JS, which is kind of the classical way of interacting with contracts, and then also Starknet React, which is a really cool library that's built on top of Starknet JS, and it gives you these React-like hooks to use to interact with the contract, call functions, write to the contract, do multi-calls. And so we're just going to do a quick compare and contrast. So you can find this, it's Apibara Starknet React. For this demo, I'm going to be using the Next.js template that's provided. So you don't really have to be familiar with Next.js for this, but essentially it just gives you a framework template to spin up a web page very quickly and have different like API routes and stuff. So I've cloned this example here, and I have a basic skeleton. So I'm just going to start the server here, npm run dev. It's going to start up on localhost 3000. So in the index here, basically I have 2 pages, 2 links. The first one is going to be an example that we're going to build in Starknet JS. And the second one is an example that we're going to build in Starknet React. So if you look at the 2 pages, they're pretty much exactly the same, really basic. We're really not worried about like any styling or anything. We just want to show how can we connect to the contract and read some variables and write the variables and basically play the game. So we can see we have at the top here some basic information to connect the wallet. And then we have the getters and the storage variables that Mikey has written in the contract. So whatever the current number that's deployed, whether or not the game is active, who the last winner is, and my number of wins based off of whatever wallet has been connected. So our goal here is to fill this out so we can actually show the data and read the data from the chain. And then I have an input here that's going to let us play the game and add up the sum and write to the contract. And then a list of transactions. So this is going to be the Starknet JS page. This is going to be the Starknet React page. And they pretty much look exactly the same. So the first thing I want to do is look at this contract that Mikey has deployed. So I have a constants file here that I'm just going to write the address of the contract. So I'm going to save that. And I've hooked it in. So we just deploy this, or we show the contract here, and we can click it, and it will take us to the Voyager. So it looks like his contract has been deployed right now. So on Voyager, we can kind of read and write to the contract, kind of see and interact with it. So let's just take a look. So the functions that he provided, if you go to this read contract tab, we have an owner. So Mikey's wallet was the owner. This was the account that deployed the contract. So if we try to read this in hex, we should be able to see, okay, this is Mikey's wallet address here. What's the current number? So I think he defaulted it to 1234, so we can query 1234. Same thing with is active. Right now, it's just a Boolean, which is just a felt 0 or 1. And we can see that the game is currently active. Similarly, who the last winner is, nobody has won yet. And this one is get number of wins. So this one actually takes an address and then it says how many wins this user has. So contract was just deployed. Nobody's played the game. Nobody has won. So I've copied these functions, the names of these functions, into the contract constants file. And now we're going to start implementing in Starknet. Let's start with Starknet React. So if we go over here, the first thing we want to do is connect to wallet, right? So Starknet React has a really great way to do that. It's really easy. Basically, you just wrap your entire page in the Starknet provider, and they provide a hook here called get installed injected connectors. And this will give you all the connectors. So that's like all the wallets. So it could be ArginX or Bravos that are the user has installed in their browser. And basically, this is going to allow us to connect the wallet on our app. So this is kind of the root page. And if we look at the Starknet React page, I've included this connect wallet component. So this is, you don't really have to worry about this dynamic thing. It's a Next.js thing, but this contract wallet, connect wallet component is part of the template that Starknet React gives you. And it basically gives you a way to show these 2 buttons here, like connect ArginX or connect Bravos. So the hooks here are going to be use Starknet. So this is a hook that they give you, and it's going to give you the account that is connected, which is just a string. So it's just the address. And then there's some connectors here. So you can have the use connectors hook, and that'll give you the functions to connect the wallet or disconnect the wallet. Essentially what they're doing is they're saying, okay, what wallets are available? And we will map some buttons to actually connect them when that's connected. So I have two browser wallets installed here, Argentx and Bravos. So this is how you can connect the wallet for Argentx. And switching over to Starknet JS, basically the way you would connect a wallet there is, I'm going to look at the SNJS code. I've written a little bit of code. I created a button here called Connect Wallet, and when you click it, it's going to call this Connect Wallet function that I defined. So this is kind of the standard way of connecting a wallet with Starknet JS. If you see, I have this Starknet variable, and this comes from Starknet JS. It's a Starknet window object. So this is TypeScript. If you are not familiar with that, basically lets you use types in JavaScript, and it's really nice. So I'm defining the Starknet object at the root of the page. So it's going to be the window object. And this is going to be how we interact with the contract using Starknet JS. So we're going to call this connect function, which is given to us from get Starknet, which is also a package that Starknet JS recommends to use. And what this is going to do is basically like, it'll pop up your wallet if I click it and say, okay, which wallet do you want to connect to, Argentx or Bravos? And then when you click it, it's going to pop up Argentx, say, do you want to connect to this application? So I will connect my Argentx. And once that happens, I get this Starknet object that's defined, and then I call enable on the Starknet, and that's going to activate the Starknet JS code. And then I just have a state variable here in my web page just to show the address, whatever address is connected. So this one is 0x8609. And then if we go over here on the Starknet React example, we're going to be able to see same thing. It could detect that my account was just connected. Okay, so now that we've connected a wallet, let's move on to actually read some of these values from the contract. So the first thing we want to do is let's read what the current number is, which is 1234, right? That's the default one that we just saw on the Block Explorer here, 1234. So let's start with Starknet React. Just gonna get my code ready. Okay, so I have set up some React state variables. Right now, current number is active, last winner, and my win. So this is basically what I'm going to set to display it in the UI. But now we actually need to connect it to the blockchain. So the first thing we're going to do for Starknet React is we're going to create a contract object. We're going to call it the sum game contract, because that's what we're playing. We're playing this game where we try to sum up the digits. So with Starknet React, pretty much everything is a hook. So I created a hook here called use sum game contract, and we're going to have to go implement this right now. So I have a helper function over here in the hooks sum game, and we want to implement some object that Starknet React is going to give us that's going to allow us to interact with this contract. So we can use the built-in use contract hook in Starknet React, and you can see we give it two things, right? We give it an ABI and an address of the contract that we're trying to interact with. So the ABI, we got to go find the ABI. You can do that over here in the code tab of the Block Explorer. And you can see here, this is the contract ABI. Basically, it defines kind of the interface to how the external world can interact with this contract. I was not the person who deployed this contract, so Mikey compiled it and deployed it, and he actually has the ABI. And it says the contract source is not verified, so I'm not sure you can always get the ABI, but for this one, we do have it. So I'm going to go over to this ABI file. I do already have it from before, but I'm just going to paste the new one. So we have our ABI. And so now we're going to use it. We're going to say, okay, the ABI is sum game ABI, basically importing this JSON file, this JSON object from this sum game .json file. And then the last thing you have to give it is an address. So this address here, just copy it from the URL. I copied it correctly. And okay, so this is going to give us a object that we can use to interact with the contract in Starknet React. So now we have this contract object. And what we want to do is we want to read some values. So now that we have the contract object, we're going to say, the first thing we want to read is what is the current number? So we're going to say current number result is, so we have another hook here that Starknet React gives us called use Starknet call. And this is going to allow us to call a view function, a getter, with a couple of different arguments. So it says what we have to give it is we have to give it a contract object, the method we want to call, and some additional arguments. So the contract we want to call is the contract that we just defined from this hook from useSumGame contract. So we can say we want to call the SumGame contract. The method we want to call here is get the current number. So this is the entry point for getting the current number. It's literally just the string get current number, which we can once again find here in the read contract tab. And any args that we want to pass it. So this is like call data. For this one, it doesn't take any arguments, so we can just give it an empty array. And then the last thing that Starknet React gives, which is kind of cool, is an options value. So basically, we can say, do we want this to be in watch mode? What this will do is it'll basically read the contract and call this function every once in a while to basically auto update it without you having to do anything. So this should be reading the current number from the contract and storing it in this current number result variable. The next thing we want to do is actually update the state variable I have here that's actually going to show it in the UI. So I'm going to use a effect for this. So this is another hook built into React. Basically, I'm going to say whenever the cur_num result changes, so the second argument that you give is an array for a dependency, fire this effect, and then I want to update the current number state variable. So this comes in as a kind of like an array-like object. So make sure that it's defined, make sure it has a length greater than 0, and then we can set the current number to, I happen to know how to parse this here. We look at the 0th element and we just call toNumber because it's like a BN, a big number. So that was all kind of a lot. Let's see if it works. So I'm going to save this. And now we can see in the Starknet React page, we are successfully reading the value 1234 from the contract. So that's kind of a way, and it's going to auto update. So if Mikey goes and updates this number, it will automatically refresh because of this watch mode equals true. So that's how you do it with the Starknet React. So real quickly, let's try to do it with Starknet JS also and show that 1234 number here. So I'm going to switch over to my Starknet JS page, which looks very similar. So I have this function here called read game state. So we're going to fill this out. So we're going to try to read the current number first. So kind of the same thing. We're going to store it in a response. Cur_num response is await. So we're going to use this Starknet object that we defined before, starknet.account. So this account object can be used to read the values of a contract. .call contract. And so this is kind of the same thing. This is what you call to read view functions in a contract. And you can see it takes an argument called invoke transaction, which is a type call. So we're going to have to fill that out. And then it also takes a block identifier. So the second argument we're going to pass here is basically saying block identifier. We just want this information from the latest block. So let's see what call contract takes. It's a type call, which is of type invocation. It's basically trying to figure out, okay, what do we actually need to give this call contract function? So we got to give it the address. So contract address is, I stored it in a variable, some contract game address. We have to give it the entry point. So which function we want to call, which is the get cur number entry point here. And the, let's see, what else do we need to give it? The call data. So these are the arguments. This one doesn't take any arguments, so we can just give it an empty array. So now that we're reading the game state, this should call the contract, and you can notice that we didn't actually need to give it any ABI here compared to Starknet React, where we actually had to set up this hook here to use the contract with the ABI. With this Starknet JS account object, when you just call contract, you can just give it the contract address and the function you want to call, which is kind of nice. Starknet JS also has a contract object that you can give it an ABI and interact with it and do more stuff. But for this example, we're just going to use call contract. Okay, so that it should give us the value in the current number. So kind of the same thing here. I'm going to take that response, which is in like a big number-ish kind of format, and I'm just going to parse it and set it to the state variable that's being shown in the UI. So I'm going to say parse int kernum response 0. And I've stored this as a string. So I'm just going to call toString. So toString. It's not liking this though. Let's see. Parse int. Let's try this. Oh, there we go. Yeah, I just pasted it wrong. Okay. Now, something that Starknet React gave us that Starknet JS doesn't give us is that watch mode. So I'm going to kind of build my own watch mode really quickly because we'd have to basically call this function every time we want to read the value if we want like live updates on our site. So I'm going to set up an interval to call this read game state function every like 10 seconds, for example, just so we can get live updates anytime that changes on chain. So I also have an effect here. Basically, whenever this Starknet object changes, like for example, when a wallet is connected, we're going to be able to fire this effect and start the interval. So we have this Starknet account object to call the contract. So Starknet and basically I'm saying, and I'm going to store the interval ID here. This is a built-in browser function, basically call some function on some specified interval. I'm going to say, okay, set interval. I want to call read game state every, let's say 10 seconds. You have to give it in milliseconds. So you multiply by 1,000. And then, so this sets up the interval, and then I'm going to read the game state immediately. Okay, so with all of that, hopefully we can refresh the page here with Starknet JS, and you can see we are correctly reading the value from the contract number 1234. So it's kind of an example of how you can read values. So there's like 3 more. I'm just going to try to go through these really quickly in the interest of time, so we can tell whether the game is active. Right now it just says false because it's not actually being read. So let's see, for the Starknet React example, I'm going to basically define another Starknet call hook, where here we're calling isActive instead. And the format is pretty much exactly the same, except this method that we're calling is changing. So I'm going to pull this out into a helper function called getCallObject. And that's going to just basically let us give a method and some args. So this is going to call the getCurNumber. This is going to call the getIsActive. This is going to call get the last winner. And finally, we're going to say, okay, get the number of wins that I have. So the last one is kind of interesting because you actually have to pass it an account, right? So if you go look back here, if we want to get the number of wins, we have to give it an address. So we're going to pass it the account that was connected in the browser wallet. And then I'm going to set up some hooks. Again, basically the same format. Anytime these values are read, we're going to fire this hook and then update it. So hopefully this all worked for the number sum game, Starknet React. So now we can see we're correctly reading is active. There is no last winner, nobody's played, and my wins is also 0. So let's do the same thing for Starknet JS. Let's go back to that example. So we're going to fill out the rest of our read game state function. I'm also going to create a nice convenience helper method to get this object, because it's pretty much always the same, right? It's the contract, what function you want to call, and the call data. So I'm just going to call this call the contract. And then I'm going to say, okay, call the contract with this get cur number entry point. Read if the game is active. So same thing, we're calling get is active, get the last winner. Let's see if this one works. And now we can see, yep, it's correctly reading the last winner. The game is active. And finally, we need to call get my number of wins, right? Okay, so same thing, we have to pass it an address here because it takes an argument. So if we call this one, we see, okay, we get some error. Unhandled runtime error, call data, expected int string got, looks like some hex string. So this is an example of, well, some weird error that we get that we don't really know how to solve. We can also go to Triality, search for this. You could also search in Discords. Sometimes, they're not always there. They can be hard to find. So it looks like our answer here is on Triality. Expected int string got some hex string, it looks like. And if we can see, basically it says we're trying to use call contract with a hex string, but the gateway is expecting an int string. To fix it, I need to convert the hex string, which is base 16, into an int string, base 10. And then it gives us the line to do it, basically. You convert it to a big number, to string it in base 10. So let's just try this right here. Save that. Refresh the page, and we can see, okay, error goes away, and we're able to read all the values from the contract. So real quickly, we only have a couple of minutes left, but let's try to implement writing the values. So we want to actually solve this puzzle, right? We want to add up all the numbers 1, 2, 3, 4 and write to the contract. So we have verify sum. So we can post our answer in here, 1 + 2 + 3 + 4. And let's do that in Starknet React first. So we want to verify the sum. So we are going to create another hook. It's kind of the Starknet React way, is you have all these hooks. This one's called invoke. So this is use Starknet invoke. This is going to let us call the contract. So we have to give it the contract that we're going to call, contract, which is this contract hook that we created earlier, sum game contract. And the method we want to call here is verify sum. So I think I have that as a verify sum as a constant over here. So this is going to give us a function that we can call now to actually verify the sum. So when we call this, we're going to basically the button verify sum. On click is going to call this verify sum function. So when we actually click the button, we want to invoke this and say, okay, what do we have to give it? We have to give it some args. So the args is going to be whatever I've typed into that input box, which I've stored in this my answer state variable. And with Starknet React, you can give it some additional metadata, which is kind of cool. It lets you track your transactions, and they have a whole transaction manager that will let you kind of view the data of your transactions with this metadata method. You can say, okay, this is the method I called, which was verify sum. And if I want, you can give it a message to say like verifying sum of, let's see, whatever the current number is. as my answer. This is kind of the transaction that I'm going to submit in plain English. And then we can clear out the input. So if we go here now and we say, okay, what's 1 + 2 + 3 + 4? It looks like it's like, let's just say something wrong, like 15. We click verify sum. Now it's going to call this invoke function over here, and it's going to pop up a transaction in Arginx to say, okay, I'm calling the verify sum method of this contract with this call data, which is the 15, which is the args. Sure, I'll approve it. And now we can see this is the transaction manager for Starknet React, and it gives you a nice list of all the transactions you've submitted with the metadata that you've added. And then this is a link to the block explorer this transaction isn't posted yet. So that's how you can call a function in Starknet React real quickly in Starknet JS. Let's kind of do a similar thing. We also have a verify sum function that we're going to want to call here. So with Starknet JS, we're going to create a transaction object that kind of looks similar. We're going to give it a contract address. It looks similar to what we created up here, which is the sum game contract address. The entry point we want to call, which is the verify sum, and the arguments that we want to pass in. It's actually called call data, as whatever I've typed into the input box there. Okay, so when we actually execute this transaction, we can say starknet.account. So instead of calling call contract, which read the contract, we're going to call execute, which is going to actually write to the contract. And we can just give it this transaction object that we submitted. So let's just try to write the correct answer real quick. JS. So the correct answer, you can see it didn't update. The game is still active because I put 15, which was wrong. Let's try to do 10. Looks very similar, right? Starknet JS, pretty much the same thing. Verify sum, this details, and now we can approve. Oh, it got a error. 11 does not equal 10. Interesting. Okay, I think we can kind of stop there. You can see we kind of covered a lot here, but you can see how we can read from and write to this contract that was deployed using kind of two different technologies, Starknet JS and Starknet React. So we only have two or 3 minutes left, but if we have any questions, then we can answer them.
Thanks, Matt. Yeah, so thank you guys for going on the journey with us. Obviously, that was a bit of a process, but we wanted to show, because we've gotten quite a few questions about going on an end-to-end journey of building Cairo contracts and connecting them to a web app. And this hopefully is helpful for people who are, especially who are new to the ecosystem and want to explore Starknet React, Starknet JS, and see how some contracts could be created, deployed. Feel free to slow down our video. And of course, we had to kind of breeze through this, but if you have any questions, feel free to reach out to us and we'd be very happy to sit down and help anyone along their way. We will be posting some educational content in the coming weeks on Triality as well, just giving some more resources for people to be able to learn Cairo, be familiar with all the different types of technologies and whatnot in the Starknet ecosystem. Thank you all for joining. Does anyone have any questions? Okay, well, thank you all for tuning in, and hopefully we'll see you around. Yes, there's a, sorry, I just saw the question. There's a repo for this. We will share it via the Topology team. and make sure that it's accessible for everyone. And we didn't get to like multi-calls and a couple of other things that we've added to the repo, but it's all clearly labeled with comments and everything. So it should be pretty self-explanatory. And we put in a bunch of good stuff. Oh, Matt posted the repo there if you want to have a look at it, but we'll make sure to post it on Twitter and other mediums so everyone has access. All right. Thanks, guys.
Thank you.